PurpleTeam is a security regression testing CLI and software as a service, targeting web applications and APIs. The CLI is specifically targeted at sitting within your build pipelines, but can also be run manually. The SaaS that does the security testing of your applications and or APIs can be deployed anywhere. So it's been about a 3.8-year journey so far that's brought PurpleTeam from the proof of concept to where it is now. I finished writing a book series to help developers upskill their security. That would have been probably around 4 years ago, which had the proof of concept inside that, which PurpleTeam was grown out of. So I ran lots of workshops with the proof of concept to elicit developer feedback and confirm that what I wrote about was true and valid. Most of that time's been like 7 days a week and 2 full-time jobs, pretty much until recently, until we've had some customers basically come on board and actually start to pay. So building a tool that helps developers write secure code is a great way to learn about security. If you want to learn more about information security, we can assign a mentor to you to help you to help yourself and the community by building PurpleTeam out. Okay, so this is a high-level architectural overview of PurpleTeam. So this is OWASP PurpleTeam or PurpleTeam local. It runs in the local environment. So what you can see up here is your system under test. So that could be a web application or API that you have decided that you want testing. We've got the CLI here, and we've got the back end, which has all the components that does most of the work. So the CLI will make a initial request to the orchestrator. The orchestrator is responsible for the testers. Currently, there's 3 testers, although the server scanner is currently stubbed out. It's not yet implemented. We've recently implemented the TLS scanner. So the testers themselves are responsible for emissaries. Now, the emissaries are the actual parts that do the scanning and that sort of thing. So for the app tester, we're using Zap, and we use Selenium to proxy the initial requests through Zap. So the stage 2 containers, basically they are Zap and Selenium currently. They're hosted on Docker Compose UI locally, and the test SSL.sh emissary for the TLS scanner tester sits within the TLS scanner container, because there's no need for it to be out external. So what happens is the emissaries actually, when a job file gets sent through from the CLI to the orchestrator, the orchestrator does a whole lot of validation and stuff like that, then passes it on to the testers. Then the testers decide how many test sessions there are. For the TLS scanner, there's only ever 1, but for the application scanner, there could be, I've got a soft limit of 12, but usually it's way less than that. So if, for example, you've got 2 test sessions, then the application scanner will spin up 2 sets of emissaries. So there'll be 2 Zap containers and 2 Selenium containers. Those Zap and Selenium always work hand in hand. Yeah, in order to spin these containers up, the testers make, or the application scanner makes a request to some Lambda functions, or a Lambda function, which is sitting on SAM CLI locally, and then that spins up these containers and then brings them down again after the testing's complete. So all the events basically that are happening in real time are pushed onto Redis channels, and then the orchestrator ends up with those messages because it's subscribed to each of those channels. If you're using server-sent events, which generally you will be if you're running the whole shebang locally, then as the subscribed messages come in from Redis, they're just pushed straight to the CLI. If you decide to use long polling, then the orchestrator pushes those messages back into Redis lists and then pops them off the lists as requests come in from the CLI. So that's sort of a rundown of all the back-end and front-end components there. How does PurpleTeam help us as developers? How does PurpleTeam help us as a business that creates software? And why would I want PurpleTeam in my build pipelines at all? To answer these questions, I'm going to take you back to a section that's in a number of my previous talks. Traditionally, how have we found security bugs in the software we write? Basically, we haven't really, or we've done it really late. Sort of like ambulance at the bottom of the cliff. So our red team has a week or two to find all the defects we've been conscientiously adding for months. Generally, a red team will cost you about 20K per week, and the engagement will be like 2 weeks for a small to medium-sized web application. Software project before release for small to medium-sized sort of thing is going to be 6 months. So that'll be about 40 grand for a 6-month project. So that's just for the red teaming. Generally 5 criticals, 10 highs, 10 mediums, 10 low severity bugs. This is just an average will be found, and that's if you're lucky. Many bugs are left unfound waiting to be exploited. The business often only fixes the 5 criticals because it's now so expensive at this point in time to fix them. So each bug has an average cost of 15 plus times what it would have cost to find and fix them if they were found and fixed when they were introduced. Okay, so how do we actually set up PurpleTeam? So head to the setup page now. Okay, so first of all, you have to set up the Docker network. Basically, this list here is just the there's a list of the components we're going to scroll through on the setup page. So you've got to set up a Docker network. You can do that manually, or it will be done automatically when you run the stage 1 compose file for the first time. So either or. You obviously need a system under test. We often use NodeGoat for our application if we're testing our web apps as opposed to APIs. If you decided you wanted to take it for a test run, you can use the likes of this override file just to apply to the NodeGoat's existing Docker compose file, which will add it into the our PurpleTeam Docker network so that it can reach it locally. We use our PurpleTeam infrastructure as code system under test. This is a Terraform project which allows us to quickly deploy any system under test that we want, providing you've got the source code for it. So yeah, feel free to take this project for a spin as well if you want. It's great for getting systems under test up and running quickly. So then we've got the Lambda functions. The details are on the README linked to here. The stage 2 containers, similarly, details on the README. There's not a lot to set up with those. The orchestrator, you'll need to set up an environment variable, and if you've got a firewall running, you'll need to create some firewall rules. You need host IP forwarding turned on, and any additional setup details are on the README link to there. For the actual testers themselves, as I said, the server scanner is still not implemented. The application scanner and TLS scanner are. The details for those setups are on the README. There's very little to do there because it's mostly taken care of with the Docker compose file. And the PurpleTeam CLI, which is a bit of configuration, after the install. Let's just have a look at that. So that's the contents there. Yeah, okay. So to actually install, there's at least three options there, three main options that we use. So cloning the Git repository is a good option if you're planning on running or debugging PurpleTeam standalone with a UI. npm install locally is a good option if you're planning on running or debugging PurpleTeam as a spawned Node.js subprocess. For example, if your build pipeline is predominantly Node.js, and the npm install globally option is a good option for running if your build pipeline is in a different language. Also, another option is the likes of npm link, which allows you to have your source code all cloned or forked locally, and you can, by running npm link, you have a system-wide command, so that allows you to basically allows you to run a PurpleTeam CLI from the source code just by linking that up. So the workflows for the CLI again are just listed here. So we take the same three options, 1, 2, and 3, and then we've just got a little bit of details under those for actually running the CLI. There's not a lot to it. It's fairly straightforward. Of course, there's the configuration to be done as well. So once you've actually got this installed, you'll need a job file, which I'll show you shortly. And you'll need to configure the actual values that are in the config file. And there's some details here around UI, whether you're using the UI or whether you're using no UI, which is basically just headless mode. So emulating the AWS Lambda service. So these are the commands that you'll need if you're actually doing this manually. Generally, you won't use these if you're just running it as like a full system test run, which I'll show you shortly. But the commands are there if you need them. Everything's here if you actually need it. Debugging. So I've got details here for debugging your lambdas. And the application scanner and any sub-processes, which is Cucumber at the moment. So you can debug into the app scanner and then you can debug into the sub-processes reasonably easy. So those are the steps for that. The other testers are a lot simpler because they don't, because there's just one test session for the likes of the TLS scanner, and the orchestrator doesn't have any sub-processes. And the front end, some debugging details there as well, and the full system test run, which is actually the next slide. Steps there for that. So the Docker Compose UI, which brings up the stage 1 containers, host your Lambda function. So I show you all this soon, actually in a running demo by way of video. So you host your Lambda functions, make sure your system under test running and accessible. So you run the Docker Compose to bring up the stage 1 containers. So stage 1 is your orchestrator and your testers. and then start the CLI, and then that actually talks to your back end, and that's pretty much it for that. Okay, so I'm just going to change my screen sharing setup so that you can actually hear the audio of this.
Hi, today I'm going to show you a test run with the backend components as well. I'm starting Docker stats to show you which containers are coming and going. We start Docker Compose UI, which is responsible for taking orders from our Lambda functions to start and stop the stage 2 containers. We start SAM local, which is responsible for hosting our Lambda functions locally. And we already have our system under test running. Now, once we've built our stage 1 images with npm run dc-build, we can bring them up with npm run dc-up, and then we start the CLI. In the bottom left terminal, you can see the validated, filtered, and sanitized job file contents. In the top right terminal, Docker stats is showing us the stage 2 containers being brought up. In the bottom left terminal, we're checking and retrying that the stage 2 containers have come up and are responsive. All testers are now running. As the test run progresses, in the CLI tester complete panel, that's the donut meters, you will see the percentages progress. These are total percentages per tester. In the running statistics panel, just to the right of the donut meters, each row represents a test session as defined in the job file. Here I'm tailing the CLI TLS tester log just to save right arrowing on the CLI terminal to the TLS tester screen and not being able to also see the app tester progress. Back to the running statistics panel. The thresholds you see are also defined in the job file as alert thresholds. A given test session will be considered a fail if the bug count exceeds the alert threshold. Alert thresholds are useful for brownfields projects where you have existing defects but still want a test to pass. These are the definitions. You may find yourself referring to these quite often. Back to the running statistics panel. You'll notice a complete column. These cells represent percentage complete of the test session, where you may have more than one of these for a given tester. In order to initiate a test run, the build user needs to define and supply a job file. This is the documentation that will help explain the schema and help you construct your job file. Next, I'll show you some example job files. This job file is very similar to the one we're using for this test run, except we're targeting nodegoat.sut.purpleteam-labs.com, which is deployed using the PurpleTeam infrastructure as code system under test project. The new bugs panel of the CLI shows bugs over and above any specified alert thresholds. If this count is above 0, then you are going to have at least one failed test session. The total tester progress meter to the right of new bugs shows the combined progress of all testers. These logs I'm showing you are the raw CLI logs taken from the current finished test run. This particular log is from the low priv user test session of the current test run, currently being written to the top of the two CLI window panes as we speak. You'll notice that this particular test session is only testing a single route, the profile route of our system under test. This particular log is from the admin user test session of the current test run, currently being written to the bottom of the two CLI window panes as we speak. This test session is testing two of our system under test routes, the profile route followed by the memos route. As you can see, the server tester is currently inactive. The TLS tester log. There's only ever one of these per test run. You'll notice the color codes in amongst the text. These are used to display the log text in color. We'll see how this works soon. We're looking at the same CLI logs as before. Tools such as cat, less and tail, if configured correctly, will render the color codes. Just reiterating that these CLI logs are currently being written. I've just taken them from the finished test run. This is the low priv user test session CLI log from the application tester. As you can see, this is a failed test session. This is the one and only TLS scanner test session CLI log that I showed you before, but with the color codes rendered. These CLI logs are what is printed to the CLI terminal if you are running it in CUI mode versus no UI mode. Right arrowing and left arrowing in the CLI terminal will switch between the different tester windows. As you can see, this is a failed test session. When you see the outcomes have been downloaded to message, that means the test run is complete and you can now inspect the report files generated by the emissaries and the result files generated by Cucumber. This is what the outcomes archive looks like once it's been packed by the orchestrator and sent to the CLI. You'll notice the report and result files. This is the HTML report file generated by the application emissary, Zap proxy, for the low priv user app scanner test session. It lists the alerts or defects, along with how they were found, how you can reproduce them, as well as directions for fixing them. This is the HTML report file generated by the application emissary for the admin user app scanner test session. This is the HTML report file generated by the TLS emissary, testSSL.sh, for the one and only TLS scanner test session. This is the Markdown report file generated by the application emissary for the low priv user app scanner test session. This is the Markdown report file generated by the application emissary for the admin user app scanner test session. This is the CSV report file generated by the TLS emissary for the one and only TLS scanner test session. Here I'm highlighting the severity levels. These can be one of low, medium, high or critical. Refer to the job file documentation for further details on these. This is the JSON report file generated by the TLS emissary for the one and only TLS scanner test session. These are the three ND-JSON result files generated by Cucumber for the 3 test sessions. Low-Priv user app scanner test session, admin user app scanner test session, and the one and only TLS scanner test session. The app scanner admin user test session for the profile route has completed. It's now starting on the memos route. The app scanner low-priv user test session for the single profile route has finished. The log which has just scrolled off the screen provides defect counts and details of where to look in the reports. This is the log and outcomes files documentation. The app scanner admin user test session for the memos route has completed, which means the test session it's in is finished. In this case, both low-priv user and admin user test sessions have failed. The CLI log file that I showed earlier contains details of how to use the report files to locate and remediate the defects. Stage 2 containers have been brought down. Now we've just right arrowed to the TLS tester to watch it finish. The test session for the TLS scanner has now finished. This also failed because the defect count exceeded the alert threshold that the build user defined in the job file. You may also notice that the total tester progress meter hasn't reached 100%. This is because the server scanner isn't currently enabled. As you can see, the outcomes files have been downloaded for you to inspect.
Cool. So that was a full run through of PurpleTeam, a full test run with a couple of test sessions there. So remember, we're looking for contributors to help work on PurpleTeam as well. I'm on the OWASP Slack as well currently. If you have any questions later on, then jump on there and ping me and I'll answer back. So that's pretty much it from my talk. I guess it's if anyone's got any questions now.